Hello, friends. Welcome. My name is Monty Paulson. I lead the Passive House team at REH Building Science, and I am deeply honored to welcome each and every one of you to tonight's Global Passive House Happy Hour, hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all Passive House tribes, as well as anyone else working to create zero emissions buildings with radically lowered embodied carbon. So please turn on your cameras. We want to see your face. Turn on your microphones. For a minute here, we want to hear your voice. Raise a glass, and we're going to make a toast to the fashion accessory of the year, to face masks.
Cheers.
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 All right. Well, cheers, everybody. So now close that other app you've got open because we have a great lineup this evening. First, we have a short video about a fascinating interfit retrofit of a textile factory in Sri Lanka. And then following up on the great panel discussion, today's NAPHN conference, Stacy Smedley is going to share some lessons learned from modeling embodied carbon. Now, during one of the recent breakout sessions, I was asked why a Passive House group cares about embodied carbon. And so just so we're clear, the Passive House standard itself, neither one of them place no requirements on building materials. You could construct a certified Passive House out of chicken wire and spray foam if you had nothing better to do. But if you're like me, when you looked at those pictures of Mount Rushmore last weekend, and you saw all that rubble, see that huge pile of rubble down at the bottom there? Uh-oh, I lost my, when the screen got big, I lost something here. Give me half a sec. And you saw that huge pile of rubble down there, and if you're like me, the first thing you thought is, man, that's free granite. How do I get a hold of some of that? And the second thing in your mind is, how many trips to South Dakota would it take for me to pick up 500,000 tons of free granite in my pickup truck? Now, do you see what just happened right there? In no time at all, my lust for free rock brought me up against an embodied carbon calculation. For when one considers the embodied carbon of granite, the answer varies depending on how far you have to drive your truck to go pick up the free rock. And our calculations also need to consider not only the material itself, but everything that goes into bringing the material on site and everything that goes into getting rid of the material at the end of our life. And because these matter, this is why we're looking at embodied carbon. Then too, when one considers the operational carbon emissions of a building one might construct with Mount Rushmore granite, the answer depends on whether or not the building is going to attract presidential entourages and other forms of fireworks. And on that note, let me introduce my co-host, Prudence Ferreira.
Monty, you've always got interesting things happening in that brain of yours. I'm Prudence Ferreira. I lead the Passive House practice for Morrison Hershfield's 22 offices across North America. And if you're joining for the first time, welcome to Global Passive House Happy Hour number 17. We love newcomers, and what I mean by that is we love your questions, your perspective, and your curiosity. We're a bunch of fun-loving geeks who get excited about sharing our bright ideas, our challenges, and brain trust of collective experience. I've been doing this Passive House thing for over a decade, and though Passive House resources and forums have come and gone over the years, I'm really excited about what's happening at Passive House Accelerator. We want to make it even better and even more useful as a clearinghouse for unbiased, standard agnostic information, all things passive. So we want to hear what's on your wish list. Later on in the show, Michael Angui is going to give us some info on how you can get us your valued feedback. So your feedback's not the only thing we want. We still want your videos. And we want to celebrate the cross-section of your renegade cell phone filmmaking skills and your Passive House projects. We're polite and appreciative guests, so invite us over for a tour. For tonight's tour, we're headed to that little spot between the Bay of Bengal and the Arabian Sea. Where are you taking us, Monty, again?
We're here today in Colombo, Sri Lanka, where behind me is one of our most exciting and interesting Passive House projects. The Star Garment Product Development Center is a combination office and industrial building, where both design, sourcing, pattern making, and sewing happen under one roof.
In South Asia, there's a long history of garment manufacturing, where working conditions in local factories are often hot, humid, noisy, and poorly ventilated. JPDA's work on the Star Garment Innovation Center uses Passive House standards to renovate an old factory to increase sustainability, reduce energy use and expenses, and improve the lives of employees. Passive House is a holistic set of design principles and efficiency standards that strictly regulate the amount of energy a building can use, guaranteeing a very high level of comfort for the people inside. Its basic principles include proper insulation to reduce heat transfer, an airtight enclosure to prevent leakages, high-performance windows and doors, and an energy-efficient heat recovery ventilation system. The Star Garment Building is located in the heart of Sri Lanka, just above the equator, where the tropical climate presents challenges to designing efficient, sustainable, and comfortable buildings. Renovating the old structure, rather than demolishing and building from scratch, dramatically reduced waste, carbon emissions, and fossil fuel consumption. The existing industrial shed was first stripped down to its bare steel skeleton and concrete slab on grade. Modifications were then made to the walls and structure, and the renovation included a high-performance heating, ventilation, and air conditioning system, a complete air barrier, continuous layers of insulation on all sides, high-performance windows and doors, and an insulated roof assembly with solar panels. Energy use is projected to drop by 70%, with a 90% reduction in dehumidification energy and a 73% reduction in heat pump energy. Employees enjoy year-round comfort in a workspace that provides filtered fresh air, abundant natural light, low humidity, and consistent temperatures. Studies by researchers at Harvard University showed that employees with access to properly ventilated air boast a 60% better job performance, have 30% fewer headaches and respiratory complaints, and sleep better at night. At JPDA, we are uniquely qualified in overseeing Passive House projects. We stand out for our close collaboration with a team of the world's leading sustainable experts and engineers. Unlike other sustainability standards like LEED, Passive House is evaluated through comprehensive performance testing before and after each project is complete to ensure the building holds up to the highest standards. With the Star Garments project, JPDA was able to use our expertise in sustainable methods of design to produce a state-of-the-art project that can be replicated on any building in any climate to make significant advancements in sustainability, energy efficiency, and quality of life for millions of people around the world.
Fantastic. I still have music coming. Hopefully nobody else has that. Sorry, everybody. All right, I'm back. So we're going to go into breakout rooms now. We're going to do these just for 3 minutes. So this gives us a chance to do rapid fire introductions of one another. So set that up now, and we'll see you in 3 minutes. Hopefully you had a nice time in your breakout rooms. And I'm going to do some quick announcements before we get to the star of the show, Stacy Smedley. So we have a number of ongoing virtual gatherings that we always like to share. And so the one coming up tomorrow is the BS and Beer Show that's featuring Peter Yost and David Gauthier. On Friday, we have BS Friday with Dave Cooper and Mark Wiley, and that's going to include a lot of familiar guests as well. Prudence Ferreira, Etienne Gubler of Sika, Adam White, Sean Satamore. So that should be fun. That's on Friday. You can see the links there. Those links are interesting. They go live when the event starts. So just so you know, and I'll share all this in chat as well. We also, every Wednesday morning, so it already happened today, but every Wednesday morning, we have the Passive House Canada Building Conversations webinar with Chris Ballard. So don't miss those. And the International Passive House Association has a community meetup on July 13th called Design Journey to PH Premium, a Client's Perspective. There's a URL for that. The International Live in Future Institute is having its call for speaking proposals. It's amazing. We're already thinking about the conference for 2021. The deadline for speaking proposals is next week, Wednesday, July 15th. And the conference itself will be in April. Hopefully we'll be meeting in person by then, so it'll be in Portland. And there's the URL, as you can see. And of course, the NAPHN conference is still going on. We're just halfway through, and we have 3 more sessions or 3 more afternoons with 15 sessions. And if you haven't already registered, you can register and get access to the rest of the sessions, which have been recorded. And there's a discount code there if you want to do that. It's been a great conference so far, and we're looking forward to the 3 more Wednesdays. And finally, I want to thank our founding sponsors, Mitsubishi Electric, Zola Windows, and RDH Building Science, as well as our stakeholder partner, NYSERDA, the New York State Energy and Resource Development Authority, for making this work possible. And I also want to thank our patron sponsors, Morrison Hershfield and 475 High Performance Building Supply. And with that, I'll hand it off to Prudence.
So tonight, it's my pleasure to introduce Sustainability Shiro, who certainly earns the credential of SPAZ. And by SPAZ, I mean she does it all. Stacy Smedley is the Director of Sustainability for Skanska, and she's the Executive Director of Building Transparency. And she's a singer-songwriter with her band, Magnolia Steel Band. And her embodied carbon tool EC3 just recently won World Green Building Council Chairs Award on Global Green Building Entrepreneurship for 2019 through 2020. And Stacy has 17 half siblings that she talks to every day, one of whom she met for the first time on Oprah. While Stacy might not be a passive house geek, she will put us right into the deep end with her on embodied carbon. Stacy, we're just delighted to have you with us tonight.
Thank you very much. I'm excited to be here. Do you want me to take over the screen and start presenting some slides?
Yeah,
Yes.
please do.
I wish I could explain everything that you just mentioned in detail, but that would take a long time.
Well, there's always the after hour.
Sure. Okay, so I'm gonna go through some slides. I'm excited to just talk and dialogue and answer questions and chat about this too. And if you hear barking, it's my pug outside, and if you hear screaming, it's my kid in his bedroom. So I apologize for all of the things that are life related right now. But I just want to briefly, there's some of these slides that you've seen before. If you've seen me present or you saw the presentation earlier, I'm not going to spend a lot of time on them, but I always like to start with them because I think seeing them a million times is not a bad thing. In the poll, it said that 84% of you know what embodied carbon is, so I'm not going to explain it in detail now. But just to frame what I think is the ultimate goal is really understanding carbon in general when it comes to the built environment, how the work that we do has to be looking at this holistically. The first step is understanding that we do now have these 2 buckets of carbon emissions that are coming from our buildings. One on the operational side, of course, and of course the embodied carbon's the other half. And I like putting it in images because I think it really starts to remind us, what we're talking about. Operational energy is, of course, all the things that the buildings are doing once they're built, and embodied carbon is really everything up to that point when it comes to how we build our buildings. This is a slide that I think many people use in multiple different graphics, where it's talking about how we know now that embodied carbon is about 50% of the pie from now until 2050. This is data that's supported by Architecture 2030. And we find on average that this is actually true, but it's really important to remember that this is very dependent on where you are. So this is an example of where we took 4 projects with actual square footages in actual places and looked at them if we assumed an 80 energy use intensity and the grid mix of each of these places. So you can see with each of these projects, they've got a certain breakdown of operational versus embodied. It's very much toward the operational with an EUI that high. If you then reduce the EUI to 40 but leave them in the same place, you can see how that all of a sudden changes, right? So energy efficiency all of a sudden starts to skew the numbers, and of course the tons of carbon go down drastically with our operational energy savings. Then, if you all of a sudden take all 4 of these buildings and put them in Seattle, this is what happens. And this is showing the importance of the energy grid. So when you're looking at a project in Seattle, this is typically about what it comes down to based on the fact that we have really good code where 40 is about right from an EUI perspective, and an energy grid mix that's largely hydro. So again, just watching these things move, it's really important for us to look at this very specifically on our projects to understand that relative impact. Focus on both, but really start to target, what is that breakdown of operational versus embodied, and how are we addressing that? Of course, as code gets more stringent everywhere and our grids get cleaner, it's going to start to skew this direction. But those tons of carbon that you're seeing here when it goes from an 80 to a 40, then to a clean grid, are very large when it comes to what we're doing on the operational side in terms of savings. So again, 50-50 on average, very dependent on energy grid and how efficient our buildings are on the operational side. So we cannot just look at one or the other, it has to be both. And then just really digging into embodied carbon, because that's where my expertise is these days. This is a good slide by the Carbon Leadership Forum. And I think right now it said that 85% of you knew what embodied carbon is, but 76% of you have not yet completed an embodied carbon assessment on your projects. So this is really the time where we all understand what we're talking about and we're trying to figure out what to do. So slides like this that are really getting into what we think about when are important. And this is looking at a slide from the Carbon Leadership Forum that's talking about, what to do when. So rules of thumb are really optimize your project. Do you actually need to build the building? Can you retrofit? Can you make the building smaller to meet your goals? So you're reducing materials and program. What are you doing from that program efficiency to really reduce the size of your spaces? Square footage of project equals embodied carbon, really, when it comes to that first impact. The second is really optimizing what you're doing. So now you know what you're building, but what are the systems that are making that building up? What are you thinking about in terms of materials, structural materials, concrete versus timber, envelope A versus envelope B? So that's really the second. And the third, once you know I'm building a building out of concrete and steel, or I have this type of carpet that I need to meet a performance on, then it really gets into the transparency at the supply chain level where you're looking at, am I picking this concrete over that concrete? Am I picking this carpet over that carpet? How do I start to look at limits for materials specifically and really incentivize low carbon materials through specification and procurement? So all of these are important. It's a circle. If we do the first well, we build less. If we do the second well, we optimize our systems and pick better materials in the first place. If we do the third well, we provide low carbon options for all those materials, which then go back and reduce everything. So it is a circle, and we need to be looking at all three. This is again the slide I presented earlier, but to look at all three, there has to be ways to do that. In embodied carbon assessment, that starts with whole building life cycle assessment, and there are tools out there that help you do that. I listed 3 that are common here in the States. There are a bunch more. I'm going to show you a slide in a minute that really looks at that, but it really is looking at those optimization choices. How big is my building? LCA tools are good for that, and that's really what they're best at. Once you've made going into those material assessments, again, you really want to be able to look at what you can specify per material category. That's where the EC3 tool comes in, using environmental product declarations to be able to look at manufacturer versus manufacturer and product versus product. And really, if you do both of those things really well, you can actually realize embodied carbon savings and understand what you did. We need all of this to work well to really reduce as much as we can. And just a little bit of a dig into what this means from what these tools do. So whole building LCA tools are looking at all stages of embodied carbon from product all the way through end of life, and they're using average emissions factors. So this is talking about, you've got a whole bunch of data from a whole bunch of sources around steel. They're going to average that into one number that they use when you're doing your quantification. So it's average data to give you a good lens to look at systems comparisons and things, and is looking at all impacts. So really good at that early stage where you're trying to directionally choose things. EC3 is, again, the next step when it's getting into procurement. EC3 looks at this product stage, and that's because that product stage is typically the largest. I think you saw some slides presented by Tim during our session that looked at how that product stage could be 70 to 80% of the overall impact if you're looking at all the stages versus that A1 to A3. So when it comes to procurement, that A1 to A3 is vitally important and what we can track pretty well right now. And we're using baselines in our tool. So a baseline is a high limit where you can make reductions, again, similar to ASHRAE. So again, I'm giving you all this in context because I think it's good to hear this multiple times. All of these things are brought up in various ways, and we really need to understand the language and the literacy around all of this. but this is really what the ecosystem looks like right now. So I did this for myself because we're trying to figure out how we fit in at Building Transparency and the EC3 tool into the larger ecosystem of embodied carbon. What it's starting to tell me is that we do have all of the tools available. We have multiple choices of how we can approach this. We have multiple methodologies of where to start. And what we really want is all of these bubbles to connect to all of the bubbles. So this is not a bad slide. An ecosystem is what we need to make something thrive. It would be worse if there was 2 bubbles that had everything in them. So this is just kind of a grounding in the fact that we're not at a place now where we need to generate more tools and more data. It's just aligning that data and connecting it well in an ecosystem. And if you pick one tool over here or one approach over there, that's okay. What those of us who are working in this space need to do is really connect what we're doing to each other. So we're not creating, 20 different options of how to do every single thing. So this is a big slide, but still don't read every bubble. I had to anonymize stuff, and I'm sure there's a million things that I missed. I just couldn't fit any more bubbles on a slide. So what this gets into to me is an analogy that I've been using and thinking about because I have a 9-year-old son who loved this book called Shark versus Train, Who Will Win? And I like to apply this to how we look at embodied carbon. And this is on multiple scales. So we are an ecosystem, but you could all of a sudden think, whole building LCA versus EPDs, who will win? Or tool A versus tool B, who will win? Or baselines versus averages, who will win? And the bottom line is that it really depends on what you're trying to do. Each have their strengths and weaknesses and each have a role to play. If you're underwater, the shark's going to beat the train. If you're trying to roast a marshmallow, the train's going to beat the shark. So really understanding that it's okay to think about what you're trying to do and use that ecosystem to your advantage to find the right fit for what you're trying to do today. We're never going to have the perfect solution. And to get to that point, shark versus train does this well. None are perfect. There are some things that we're trying to do where the shark or the train's not going to work perfectly, but we still need to do it. And I think that's really grounding ourselves in the fact that if we wait for perfection and one kind of golden answer, we're never going to get anywhere. So use the ecosystem, understand the ecosystem of what we currently have available with embodied carbon, and just start to take action. And the cool part now is that we actually do have resources. So again, the ecosystem slide shows it in this kind of messy web way, which is actually really good. But if we're just looking at where we are now from an embodied and operational standpoint, you just take a snapshot of things, right? We've got tons of resources on the operational side. This is just, again, me pulling certain things that we use for baselines or reporting or resources to understand operational carbon. We now have those for embodied carbon too. So get smart about it. Go to places like the Carbon Leadership Forum, read the World Green Building Council's report on embodied carbon, read the New Carbon Architecture by Bruce King, use the resources that we have to get smart. And I always like to show an example of each of these things. So this is my call out to the Carbon Leadership Forum Embodied Carbon Network. This is a group of folks across the country and in the United States. I think now it's global. I heard there's global chapters now that are coming together to really become the hub for embodied carbon knowledge. It's all volunteer driven. There's over 15 chapters and over 2,000 network participants. So again, we have the resources available to us to really get smart and share data and information. The second is around policy. It's really important to understand that policy drives a lot of this. So if you're looking at policy, of course, we understand operational energy policy and how it works and what it's based on. There's now policy starting to pop up around embodied carbon, starting with Buy Clean, which is very much EPD driven. But there's also thoughts about how you look at carbon use intensity similar to an energy use intensity. So could you do a kilograms of CO2 per square foot to put into building code? And the last one is really, oh, there's an example. So I always forget my shout outs, but of course, this is another example of where a group of folks came together in the Bay Area and put together a low carbon concrete code, piloted it, and now it's actually being implemented. So again, this stuff is happening. It's good to look at how it's working and what they're doing. So go read the code and see if it's something that you could apply to your location. And then tools and certifications. Again, there's overlap where now programs like LEED are looking at embodied carbon through whole building life cycle assessment credits in the design phase, but also a pilot credit for the construction phase where it's all procurement based. The Living Building Challenge has had embodied carbon in it for a long time. Zero carbon certification looks at it more explicitly. And of course, we have all these tools that are now developing and in place to do both things. So again, I just like to show how now I think we're at a point with embodied carbon where it's again taking action and learning how to do that. And really, it's not rocket science what we're trying to do. We're trying to pick the lowest carbon options for our materials. And so what we're finding right now, I'm just going to give an example with this cartoon side of how this is working in things like concrete and steel. What we're finding is that by optimizing our concrete designs during the design phase, which means looking at how thick are our slabs, can we actually reduce the structure, can we use lighter, if we make the concrete lighter, that makes the steel members lighter. So there's this kind of optimization that happens in design. When it gets into procurement, it gets into disclosure through environmental product declarations, specifying the need for EPDs, and then for concrete specifically, giving performance mix requirements to a supplier and saying, here's what we need you to meet from a performance perspective. Give us your lowest embodied carbon option with an EPD to verify that. And by doing that on projects here in Seattle and other places in Skanska, we're finding a 30% reduction in the emissions for those mixes just by having the data and asking at no cost. So that's a good concrete example. We're also seeing more disclosure by asking. So people are using request letters for EPDs. We have a first precast supplier in California that's providing environmental product declarations. So really it's ask first if you don't have the data. If you have the data, use it to inform your choices. For steel, it's similar, where we have optimization during design, and then during procurement, we're actually looking at, okay, does this steel supplier have plant-specific EPDs? Can we actually go procure their members from this plant over that plant because it's a lower embodied carbon number coming from their environmental product declarations? So again, I think the message I'm trying to convey is just start. Figure out which tool you want to use. It's okay if you don't know if it's the perfect tool. None of them are perfect. It's okay if it's using average data or baseline data. It's still data that you can reduce against. And then on the supply chain side, disclosure, incentivizing manufacturers to disclose and then reduce, and then realizing your savings by knowing what you installed. And just my little plug for EC3, it is a free open access tool. That's what we built it to be. There is no paywall. The data is all available through an API. The database of EPDs is something you can pull from into any other tool. Go register for your free account and just start to dig into the data we have. We are going global, so we are trying to include data from all over the world now and fill that supply chain gap. And that's all I have. So I think that was 15 minutes. I don't really know. But thank you, and email me if you'd like to dig into any of this more. That's what I'm here for right now. Skanska's paying my salary, but I'm pretty much full-time at building transparency. So
thank you so much, Stacy. That was fantastic.
Yeah, that's great. So we've got time for questions. There's a whole pile of interesting questions and comments. Sean, are you queued up to be the question concierge?
Yes, I am. There was a lot of good stuff here. So I'm just going to go back up to John Brule had just a question about the charts. So first, John, again, the slides will be readily available. So don't worry about that. So John, I guess, did you have a specific question or chart that you wanted to get from Stacy? And if so, you saw her email address at the last slide there.
No, we're good. I screenshot it, but it's new material for me. So just having that as reference, and then, we can go from there. So appreciate that. Thank you. Gotcha.
Okay. Jeffrey X, you had a question, which I think might have been answered in the chat, but again, fire it off anyhow.
I didn't see an answer, so I'll ask it again. We're going to be doing pretty much exclusively retrofit and single family. And the answer I get when I ask, how do you account for the fact that you're reusing the vast majority of a structure? The answer I get is usually you count from zero, and then whatever you throw away, you add, and whatever you bring in, et cetera, et cetera. And it doesn't seem to sit well on my taste buds, because there's a huge carbon load that you're reutilizing, and that's going to be carried forward 50 to 80 years or however long the structure lasts. So is there a way to calculate that carbon load? Because that's a selling feature to a client.
are you talking about specifically, like, so you're reusing a building, you're not building from scratch, you're basically retrofitting an existing building, is that correct?
I'm talking specifically about single family residential, but yes, anything.
Yeah, so what this gets into creating baseline buildings, just like we would for ASHRAE, for energy code. And we're working on that where we have templates, but what we really need is a benchmarking database where you could say, here's the typical kilograms of carbon per square foot for a single family home. Here's the square footage of my home, and get that number, and then account for what you did during the retrofit and see the delta. So we're able to do that on projects at Skanska right now where we've got, 20 elementary schools that we've built. So we can actually say, okay, for these elementary schools, that's, 500 kilograms of CO2 per square foot. And if we do that, then it's, okay, if we just reuse this building and only do this much, we can actually look at the comparative embodied carbon delta.
So I mean, in my thoughts, we're going to be basically tearing this thing down to its exoskeleton and rebuilding it. So we're going to have plans for everything. Can we simply take what's existing and credit it as that material? The wood, the concrete, et cetera, et cetera?
Yes, if you know quantities or you could estimate quantities, you would be able to do that where you could create a baseline model in any tool, but EC3 would allow you to do that if I'm thinking through my EC3 brain. And then you could create the real case and then show the comparison. So here's what it is for if I built this from scratch, and here's what it is when I.
And eventually I'll have a shorthand for that by doing multiple homes, right?
Yeah.
Okay, got it. Thank you, appreciate it.
Thanks, Jeff. Justin, pop on. I know your question got answered in the queue, but I think it's a good one for everyone too.
Thank you, awesome presentation. And so I was just wondering, like, do things like the declare label, does it feed into the EC3, or how does that relate in any way? So or is that a question of the shark in the train?
No. So this is an ecosystem answer. So what we want to do is not is connect, right? So right now what's happening with EC3 data, there was a pilot with Declare where they now include an embodied carbon line item. This was piloted by Interface and Armstrong and Superior Essex, I believe. And on that line item, it's either a green dot if they're below most of our data points. So there's, the data in EC3. So you get a green dot if you're in the 20th percentile range, a black dot if you're kind of on average, and a red dot if you're high. So the declare labels are trying to pull in the data that they can get from EPDs and EC3 to actually disclose that just in kind of a green, black, red indicator on their labels. Does that help?
Yeah, totally. Thank you.
Sorry, I got distracted with chat and didn't queue up the next person. David Solomon, I know you had one. I'm going to bump you up just because it's quickly in my screen here. So
cool, thanks. Hey, Stacy, could you talk a little bit about carbon sequestering materials and specifically like CLT? And I know there's times that where say you're using wood in lieu of steel or concrete or something, right? But when is it appropriate, and how do you know if it's appropriate to take a credit for carbon sequestration versus, using a wood product where it's really not appropriate? And along with that, I'm curious about your opinion on products like Carbon Cure, and, they look really enticing. Has there been any kind of third-party verification to back up their claims? I'm just curious about what your opinion is.
Sure. So the first one, I'm not going to go too far down the wood rabbit hole because we could spend like 24 hours talking about wood and how to assess the carbon sequestration and biogenic, all those things about wood. And there's people that are far smarter than me about it. I just know enough to be dangerous. But what we're seeing, if I'm talking about how it's disclosed and how we take credit for it through third-party verified data and EPDs, what we now know with EPDs is that the A1 to A3 is just how the wood's getting from the forest to the facility and being manufactured. So that's one little lens. But for wood, what you really care about is the forest and how it was actually extracted from the forest. And you care about what happens to the wood when it's taken out of that project. And those are two things that are very variable, right? So the only real proxies for the the forest right now are certification systems like FSC, where, you know, at least it was harvested this way. There's folks that say that, you know, legal wood in the States versus, you know, rainforest wood, you could take a proxy where you know that that legal wood's just going to be better than what they're doing in the Amazon. So there's no clear answer on that one yet. But we do know that we need to get data past that mill to understand the actual forest harvesting component. If they aren't if they aren't replanting the trees, how do you account for the fact that you know, there's accounting for the carbon that those new trees are going to be then taking credit for. So it's very complicated on wood.
Yeah, and
more
sorry,
transparency is better.
right. And how do you, like, what's your baseline assumption for end of life disposal?
So there's folks that think you should take credit for wood that's going to be burned as biofuel. You know, there's the biofuel, and then there's that's really the big question that people are debating right now, is if it's being turned into fuel, it's still emitting carbon. There's all this stuff about that, and we don't really know if that's what's going to happen. It's similar to any waste stream for me. So when we're looking at projects and that stage C from a Skanska perspective, it's hard for me to say that I can be assured that I know what's going to happen to this bill of materials when it's deconstructed in 50 years by somebody else. So I'm getting like down a rabbit hole a little bit, but we try to figure out what we're doing with the project we're tearing down today and making sure those materials go into proper reuse versus projecting what we're going to do in 50 years for something. And I think it's similar in wood. And then there's even more debates about how you account for the emissions of the burning of the wood and all those things. So I don't have a clear answer on the wood side. I think we're still trying to figure it out. The Carbon Leadership Forum just did a great series on wood. It was a 4-part series where they brought in a whole bunch of experts to talk about this, and just basically all these buckets of, you know, forest, and then manufacturing, and then end of life, and the different approaches to all of that. So if you haven't, those are recorded. You can go watch them.
Yeah, I haven't.
It'd be a good like Saturday evening, you know, no Netflix, go watch Carbon Leadership Forum webinars type thing. On the Carbon Cure side, Carbon Cure is interesting. So they are venture capital invested through Breakthrough Energy Ventures and a whole bunch of folks who saw the potential of you know, sequestering carbon in concrete mixes. What they are is actual aggregate replacement, where they're putting refrigerant CO2 into the aggregate. So it's actually not CO2 being captured. It's CO2 that's a commodity item that would go to like a refrigerant in a refrigerator at 7-Eleven. So they're buying commodity CO2 right now.
So I thought that they were like, I thought they were capturing atmospheric CO2 and liquefying.
They want to be, and
But
they're
they're not.
testing it. But right now they have to purchase the CO2 off of you know, a marketplace, just like anyone else would be purchasing CO2. But the actual benefit to the Carbon Cure right now is the fact that the aggregate is cleaner or smoother, so it allows less space between it, which makes mixes get to strength faster. So you can use less cement in the Carbon Cure mixes because of how clean the aggregate is, because it's manufactured and not rock. So there is depending on the mix, somewhere between a 2 and 10% reduction in emissions by using Carbon Cure, not based on the carbon that's being sequestered, but based on the cement reduction.
Okay. Yeah. I mean, they claim, I think, 5%.
Yeah. So it's in the right range, but it's their name makes you think they're actually taking in the smokes, like the carbon that's coming out of the concrete plant and putting it back into the mix. And they want to do that. There's a cement plant in Canada that has piloted doing that themselves. So that is coming, I think, and they will take advantage of that when it does. There's just not enough of that right now for them to actually supply the CO2 they need to put into the aggregate.
Yeah, and I think Jason might have put that in the chat earlier on. I think it was Lafarge local plant. Great questions, David.
Yeah, thanks, Stacy.
Going to go over to Bronwyn. Just before Bronwyn comes on, again in the chat, Stacy, someone wanted to get an MRI of your brain because they figured it would be off the charts. So just a little shout out that you missed that lovely pat on the back. So Bronwyn, you there?
I am. Thanks, Sean. Great to have you on this, Stacy, and actually talk to you live again. My question to you is relevant to the slide you showed about other places coming on board with the EC3 tool, and I wanted to know, like, where are you seeing is sort of embodied carbon the most sort of desperately needed, and I guess I had a visit to China last year before this whole thing shut down, and I was wondering, like, where are you going next with it? And, you know, maybe how can we have, with our global network, the Passive House Network's a really great global connector, and, you know, I'd love to see how we can help.
Sure, yeah, so
on that.
There's the kind of varying needs. So if we're looking at Europe, which I think is the most advanced when it comes to the path of embodied carbon, if you're thinking about the journey, you know, they've got all sorts of standards and codes and requirements and good tools that are meeting those standards and codes, but they aren't really doing what we're now doing here when it comes to supply chain specific data and how do we actually create a way to compare it. And so our conversations with our European either clients that have offices there or, you know, suppliers in Europe is how do we bring this to get to the disclosure, that level of disclosure in a tool that allows that supply chain specific assessment. So that's one thing. They're already doing kind of LCA and all sorts of requirements around this and EPDs, but just not in a way that makes it actionable like we are now getting to here, thankfully. In places like China, we just need the data. So, you know, we've got other entities that do work there that are trying to help us reach out to suppliers and researchers and universities. And in that market, really let them kind of lead, but take what we're doing and apply it, because there's also different just cultural perspectives on how this should be rolled out in different places. But there are also global concrete suppliers and global contractors that work in multiple markets. And if they see a value of doing it in one place, they could be a good place to start to get someone to just adopt something and try it in another. So that's working with folks like the Global Cement and Concrete Association and their suppliers to start to see who would bring this at the supply chain level. Mm-hmm. India, developing countries, it's all over the place. But I think the one thing we're trying to crack is really the ability to generate EPDs quickly and at low cost, because that's also going to help adoption in places that aren't run by, you know, global concrete companies that have the funds to invest too. So that was a rambling answer, but
no, it's interesting. I mean, sort of connecting to the question that I asked in the chat for our, you know, our conference session about toxicity as well, because you know, the Europeans have done a much better job of actually limiting the toxicity of materials right at the supply chain, and I wonder, you know, that's something that we can borrow from them and get that into our supply chain, because ours just hasn't even started to, you know, scratch the surface of limiting toxicity in materials. So, you know, and definitely neither have the Chinese.
Yep,
but,
absolutely.
You know, it's yeah. I mean, I was fascinated last year about how much further along they are in actually really looking at operational energy in buildings. So I'm, you know, I'm hopeful that actually maybe bringing in the embodied carbon to the mix and the discussion there is, you know, something that I see, you know, might happen sooner than we expected, and it certainly did on the operational. That you know, was a big surprise. That was a nice unexpected one.
Yeah, no, I think there's also, you know, it seems like, you know, I don't know if this applies directly, but folks like to be first at things, and there's still the opportunity to be first in a lot of markets. So how we can drive those first adopters, I think is really important and strategic too.
Right.
All right, Brown, thank you. Morgan, you come on, and I know Mark wrote earlier that, and I agree, my daughter is a big fan of that book, and sometimes pictures just tell it a lot better. So great resource, great example. And as Monty said, it was a concrete example. Morgan, you there?
Yeah, thanks, Sean. Great presentation, Stacy. Just I'm familiar with a number of ways you can theoretically reduce emissions from concrete and cement, but I know that we're all kind of constrained to what practically is available, you know, where our project's jurisdictions are. So I wonder if you could just unpack a little bit your story of, we just asked, we got 30% at no cost, you know, where and how, what was the solution that came in that case?
Yeah, so it's interesting. So I like to talk about concrete like baking a cake. So the concrete suppliers are the master bakers, and what they really want to know is, you know, the constraints they have on things like carbohydrates and calories and things like that, right? So if we're telling them you need to meet these requirements, it needs to cure at this time, it needs to, it's going to be poured in this place for workability, it's going to be poured in October, and we want you to give us the lowest carbon option, like the low calorie concrete mix that's going to meet those 3 requirements. They know how much sugar and how much flour they can put in there and change to get the lowest calorie option, right? So a lot of it is right now, if the concrete suppliers get a concrete spec and it says, you know, maximum 25% cement replacement and, you know, blah, 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 they'll go pick the mix off the shelf that meets that without thinking about the carbon emissions and tweaking those ingredients. So they can actually reduce the cement or source the aggregate from another place and reduce the emissions without changing or not meeting your performance requirements. Does that help?
Yeah, well, was it a big project, one that was able to justify them tweaking? Because a lot of projects are small relative to the throughput of a cement plant.
Yeah, but I think it's not, there's no cost, there's no additional cost for them typically. Sometimes there's actually a savings if they're replacing cement, quite honestly. So it's just it's not even a cost, it's a freedom for them to actually right size the ingredients list versus you being prescriptive in what you're telling them to do. So performance mix requirements give them the freedom to tweak the cement replacement and tweak the aggregates and all these things that if you're giving a prescriptive spec that gives limits and all these things they can't do. So it's moving from prescriptive to performance concrete specs where you're not giving them percentages of ingredients or things like that. You're letting them decide on the ingredients.
Okay. So would it be that they fine tune to meet your spec, and then would it be the sort of upside benefit of anyone else who was using their product around that time would have gotten the same mix?
Yeah, and with EPDs, what's nice is once they create the EPD for that mix with those specific ingredients and that specific carbon content, that is now disclosed as mix number blah blah blah.
Yeah.
And the next project can say, oh, here's the 2 mixes that meet my requirements. Mix number blah 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 is lower. Now I can say, why can you use that one?
Nice.
So that's the first thing. And the second thing, you know, things that are coming online, and it's really understanding concrete and really where the emissions come from. There's a type 1L cement now that's available that is allowed in certain jurisdictions. We can use it here in Washington. And just by changing to this new cement type, it's a 10% reduction just off the bat. So there are also kind of little nuggets that you learn where it's okay, well, just by replacing this type of cement, now that this is online, we can get this reduction just right off the bat. And it's not a cost increase, it's just a different type of cement. So I think that 30% range is kind of the sweet spot of what's possible right now, just by how you're fine tuning things and really capitalizing on what is currently possible. It then gets into things like carbon cure or other innovative things that might be a cost increase. But I also think that as we are incentivizing manufacturers to innovate and we're keeping them competitive because we're having them compete on where they are now, they're going to have to be competitive on cost and carbon. So I think all of it's going to just go down. That's my moonshot, is that by doing this, by having them have to disclose all this stuff and then innovate to be the lowest, they're just going to keep on being competitive in both places.
Yeah,
so.
there's some low-hanging fruit across the whole industry right now.
Yeah.
That's great. Thank you.
Sorry, I had my mute on. Laura, are you there?
Yeah, we're here. We're here. We actually had 2 questions. Thank you, Sean.
All right, well, fire with one because we're getting close to the top of the hour, and then we can carry it on in the after hour. But fire with one, please.
Sure. The first one, at the recent FIAS conference in Washington, D.C., I saw a couple of colleagues in local Philadelphia, Past Fast Heroes, present on carbon and the carbon measuring. And there was another fellow, an engineer, who was talking about refrigerants. And refrigerants blew my mind when he was, and then there was some anecdotes about, oh, I just had to replace refrigerant in my passive house, and that was 5 years worth of energy cost up in smoke. So who's working on refrigerants, I guess is the question.
Well, this is great. I'm sorry, my dog's gonna bark now, so you can hear him a little bit, I think. But so MEP in general, mechanical, electrical, plumbing in general, whether you're talking about the embodied carbon of the products or refrigerants, are kind of this like it's the next thing that we actually need to bite off and chew on. So there are MEP firms like PAE here locally, leadership there, that are starting to quantify the refrigerant side of things. It's the leakages and all these things that are involved with that. And he has slides where it's, you know, it's comparable to a big chunk of the structural emissions that we're talking about from embodied carbon. So again, we're on this trajectory. I think MEP firms are starting to look at that, and we're also starting to look at MEP baselines for products, so that that can be something you're looking at when you're looking at envelope systems or equipment. But for refrigerants, I think PAE is a firm that I would either go Google and follow, and it might have been the folks at PAE that was giving that presentation, because they've been the most vocal and they have really good slides and statistics around this. But it's kind of uncharted territory right now.
Right, and part of it was that, you know, it's related to installation, right? Mm-hmm. It assumes you're going to lose 10% of your refrigerant every year. Yep. But what if you have a bad valve?
Yep.
You have
and
to
then it's just
fill it up. Right, exactly. That was what was so eye-opening to me. It's like, you know, it's the refrigerant which makes passive houses and you know, high-efficient buildings work, because that's the kind of systems that we use, at least in our type of climate. And it just sort of comes with the territory, and you have to assume that that carbon loss is a fact of life until someone, I know there's CO2 refrigerant work that's out there, so that you have an equivalent loss of 1, but we're not quite there yet. And you know, it's just an issue that I think we all need to recognize, and I don't know what we do about it, but it's
collateral damage, and
it is.
most people are unaware of. Right,
yep.
With going electric.
Yep.
The other question had to do with whether Skanska tweaks the concrete mix, or do you get the engineer to tweak the specification? Is it at the consumer end, as you as the consumer, or in the engineering spec?
So we are typically a contractor that's on board during pre-construction, and we influence our teams positively towards going to performance specs. So the structural engineer gets on board and actually writes that performance spec. We then use that spec in our bid documents when we procure the concrete. So it's a combined effort. It's really us saying, no, we see reductions if we do it this way. Can we do it this way? Structural engineer writes the specs and say, yes, we could do that. I'm comfortable with that. And then the suppliers have to meet the criteria.
Great.
Thank you.
Yeah, thank you.
All right, great. So I think we're gonna, this is fantastic. Thank you, Stacy. So
I've never seen a chat with like 99 plus where it can't even like quantify the number of chat lines in it. I'm trying not to read it myself to get distracted.
Don't, Stacy. I'll pull out the juicy ones for you. I'll give out, again, everyone loves you. Just take that as the day quote.
If you weren't ADD before you start participating in this call, you will be afterwards.
It's in a good way, though.
So we're going to take just a quick detour, and Michael Ingwe is going to say a few words about a project we've got underway and some feedback we want from all of you.
Cool. Hey, thanks, Zach. So first, I'd like to say that the last year with the Accelerator has been just a lot of fun. I think we truly believe that together we can do a lot in terms of sharing, creating climate change solutions, being a catalyst for zero carbon buildings. We can make a big difference, and everybody's been great. One of the best things that's happened on the site is Zach joining, and it's been, we've made a bunch of differences already, but the biggest change is what's coming. We're already part of the way through the second version of the Passive House Accelerator site. And we want your feedback. We want to know what you think works, what you think doesn't work, what sections we're missing, what you think we could do better, describe better, be critical. And instead of filling up the chat, although that might be fun, if you guys could just email Zach and he'll put his email in the chat, that would be great. And if necessary, we'll also follow up with you via a call, but it would be great to get a sense from you about what you think could be better. Thanks.
Yeah, awesome. Thank you. So I will put that in chat. first I'm going to make a quick announcement about next week, which is very exciting. We have Anjanette Green with Reset scheduled to speak with us about indoor air quality. And I think that given what we're going through with COVID, a lot of us are thinking about healthy buildings and what moves make sense and what moves don't make sense, and just looking for great resource on indoor air quality in our projects. So Anjanette will be presenting and doing a deeper dive. She's going to be part of a panel on indoor air quality at the North American Passive House Network conference session earlier that day, much like Stacy was today on embodied carbon, and she'll join us later for the happy hour. So with that, I'll hand it over to Monty and Prudence.
All right. Well, thank you so much, Stacy, for your fantastic presentation. The chat has been amazing. And I hope that you stay with us into the after hour, where it's sure to be a lively discussion.
I will. I don't know how I could not at this point. So
it's a little addictive, this group.
Yes, thank you, Stacy. It's really useful. I know the discussion is going to be good. Hey, I just want to remind everybody that Passive House Accelerator will put this online, and we'll try to put Stacy's slides online. And I really liked your example showing how different the breakdown between operational and embodied could be in different utility grids around the country. And that's what we're finding as we look. It's truly been shocking to me coming from the bias of the Pacific Northwest, where hydropower is the given, and we see this huge impact of embodied. And then I go work in a region that has a lot of coal power, and it's like, whoa, no, the operational is the thing here. And so we know these relative impacts will keep changing as grids get cleaner, as we get better at low emissions buildings, and as we get better at all these things. And working towards hard caps is going to be really important across the board. And I appreciate your effort and appreciate everybody's effort to make sure we're watching both numbers for our project, not hypothetically, but for the project we're actually doing. With that note, thank you so much. Back to you, Sean.
Great, everyone. Thanks so much, Monty and Prudence, and again, the rest of the team at the Passive House Accelerator for another great happy hour. And even to Monty's in his presentation today, we talked about the four, world kind of targets when it comes to designing a passive house, and he had great tips for that. And again, and overall, I think the key is just being aware of all this stuff. Even if you just understood what embodied carbon is today, it's now on your radar. One helpful tip, because there was so much chatter, this is probably, like, I couldn't even find questions. Like, I think Travis and Perry have questions 10 minutes ago. If there was so much and you're blown away, you can actually save the chat. If you haven't done this in Zoom, where there's like three dots, like in the chat on the far right, it says like, 2, when you can put in who you want to talk to, then file. There's 3 dots. If you click on it and it says save chat, you can, once we close things off, you can get the chat, or just copy and paste the whole thing, throw it in a Word file, and be able to look forward to it. So amazing stuff. And so that being said, as we need to give Stacy another cheers, because that was awesome. So cheers to you, Stacy.